So my goal is to give you a short overview, 100 slides, what's interesting happened in NLP, natural language processing, in 2033, maybe end of 2022 as well. That's not the whole story. Some things I probably sure miss, but I believe it's more or less most of the important things. But anyway, the field is changing frequently and significantly each day, so it's hard to keep up. Maybe 3 months, these slides will be significantly outdated. So, first, some kind of philosophical background, or systematical background. A few words about foundation models. Stanford Institute published a paper in the end of 2021 about foundation models. They introduced this concept of foundation model. There were actually it was a huge paper, close to 200 pages. It's still interesting to read or at least scan through it. The basic idea was we have kind of entered in the era when some large models are trained, and then these models can be adapted to very different tests. Like was with BERT, or like it's happening right now with GPT-like models. They're pre-trained or trained, doesn't matter. They are published or not published, and later you can use this model for very different things. You already know some examples, or other examples you see here. So we are actually living in this era, and I particularly like this image from the paper. They're kind of trying to understand and build a solid picture of what's happening in the world and how it changes. So they look at the axis of emergence of something and homogenization of something. And they track how it happens with machine learning, deep learning, and foundation models. And it's interesting, it's better to read than to explain in 1 minute, but anyway, with machine learning we have several general algorithms, and in this sense, these algorithms were homogenized. You can use these algorithms for very different tasks. And during learning, the emergence, how the task is solved was kind of emergent from this data and this algorithm. With deep learning, now the architectures are homogenized. We have several architectures, CNN, RNN, before neural networks, transformers, and that's basically it. And all these architectures can be applied to very different tasks and solve very different problems well. And here, with learning these models, some features emerge with inside these networks, and that's the difference with classical machine learning, where you have to develop your own features. That's the difference between classical ML and deep learning. And finally, something new will happen probably. Right now, we are in the era of homogenization of models like BERT, GPT. They are just models, but these models can be used for very different things. They can be adapted, they can be used as this, and that's it. One model is kind of enough for many different tasks. And right now, new functionalities emerge inside these models. So, for example, when GPT model was trained just to predict the next token of the text, that's it. But suddenly, this model can solve completely different tasks. Machine translation, question answering, programming. We still at the start of understanding which task can be solved and the capabilities of this model. So since then, term foundation model is frequently used. I like this term because it shows something important, and I believe it gives us some guidelines of what could be changed and where it could be directed, but still no answers in many cases. So what's happened? The interesting part. First part, prompt engineering is now a job, normal job. The job by Henry Carpati for this new programming language is English, completely true. This year, many of you probably write different things in English to solve your computer problems. It works, it will work even better. Anthropic job description of prompt engineer with pretty decent salary. Normal work. You can apply for it even without understanding how Python works, how C++ works, how to fine-tune different systems, engineer systems. It's quite unusual actually, but it's here already. And prompt engineering is tricky. Here is an example. It's one prompt. I like this particular paper. It's a paper about constitutional AI by Anthropic. They developed kind of constitution, a large text, human readable text, that describes what's good, what's bad for agents, how agents should behave and should not. And it's a very good example of advanced prompting. Not really advanced, but deep prompting. You describe what you want, you describe how to evaluate output of the same model, and actually it also can describe how to change the output of the model given this created by this model. It's a multi-step process that can use one model but different prompts, and it can iteratively improve your results, for example, regarding safety of the chatbot agent. So here is just for an example of large prompt, and that's not the hardest thing. Inside prompt engineering specialization, a lot of techniques are available. Chain of thought, you probably heard about it. It's a very popular thing. Instead of asking the model to do something, you ask the model to explain how you will do something in steps, and then to do it in steps. And suddenly it gives much better quality than just asking to do something. And forcing model to reason about solving the task increases quality of different solutions. That's nice and that's interesting. And another interesting thing is that model can use external tools, like internet search, like calculators, like external databases, limited only by your imagination. Again, it's hard to read here about one paper called Toolformer, not the only paper, a lot of different papers on this field. Introduces just by prompts. You explain the model that you can use calculator for something, you can use calendar for something, you can use internet search for something, and then model use it for something. For example, you just insert some strings, NT, something. That means the model wants machine translation here, and you then post-process this text. When you find some text that assumes calling external tools, you just call these tools. It's a deterministic thing. You just call Google API, you just call Google Machine Translation API, you just call calculator, and put the results back here. And then GPT process these results and produce final decision. So this way you can easily fix main problem of LLMs. For example, LLMs work poorly with numbers. You can ask them to some numbers. It works when numbers are small, but big numbers produce errors. But with calculator, it's easy to make different calculations. It's perfect. No problem with these. It kind of solves not completely, but it solves the problem with hallucinations. When model does not know something, right now it can go to Google, go to some databases, find some relevant facts, recent facts maybe, and use it. So it's a very good thing, and right now models are capable of calling some external Python, for example, calling something else. And again, we're just at the beginning of this journey of which tools will be available soon to this model. And again, prompting is tricky, and many models like GPT were introduced in other systems, like in BIP, like in web interface of ChatGPT. And of course, internally, these models are blocked from producing some hard results and some other things. This can be adjusted or hacked. So there is a separate thing called jailbreaks. By very special prompts, you remove these barriers from models, so model can produce some toxic text, some harmful text. Model can explain you how to probe a bank, for example. The typical GPT does not allow you to do such a result, but with jailbreaks, you remove this protection and the model behaves as it is. So it's an interesting technique. It's just from the same field of prompt engineering, but you see that already it's kind of adversarial settings. There are people who create some clever prompt to solve the tasks, but there are other people who can create another prompts to hack previous prompts. Sometimes, in many cases, you do not see that prompt that's hidden inside the system, but you can influence it. So it somehow resembles well-known SQL injections and other injections. Looks pretty similar, and cybersecurity regarding LLMs is just emerging field. I believe it has a bright future and very interesting future. We'll see. And for those of you who remember another NLP called Neuro Linguistic Programming, it was very popular in Russia, in Soviet Union, maybe, and probably in Armenia as well. I'm not sure. It's very funny that the basic structure of how you interact with something is very similar for prompting and for that good old NLP. So it's fun that both NLPs kind of converged here. Just an observation. That's interesting. Yeah, that's it with prompting. Prompt engineer field is a very dynamic field. It's quickly changing with new models. Your old knowledge could quickly become irrelevant because everything changes extremely quickly. But it's still here and probably will be here for some years. Second, in commercial LLMs, you of course know about GPT-4, the latest, brightest GPT by OpenAI. It's not the only one. And the interesting thing is that we no longer test large language models or LLM on special machine learning benchmark. Right now we test them on human exams, and they performed pretty well. I believe GPT-4 was the first brightest paper that started to do this thing. Probably not really the first one, but they published a lot of nice pictures how GPT-4 beats different humans in different exams, or at least passes these exams with a decent level. Right now, Google Palm 2, it's Google analog of GPT-4 by Google. It does the same. Android Cloud there, another commercial LLM. It's pretty interesting because it has a very large context window, 100,000 tokens. It's really big, much better than and much wider than GPT-4. GPT-4, I believe, has only 8K tokens, maybe, and GPT-4 has a special version of 32K tokens, but it's much larger. So you essentially can put a large article into LLM and ask anything about this article, and it would work. That's interesting. There is another startup called Inflection AI producing their own LLM. Again, they compare with different LLMs on human exams as well. So that's an interesting trend. Again, there are a lot of problems with such comparisons because sometimes it produces irrelevant expectations and a lot of anthropomorphism happens here. That could be a problem anyway. You see it's happening. And there are many other commercial LLMs. So the field is pretty diverse right now. You already have many options. You can use different models. As usual, there are no one best model. You have to mix, and you have to carefully choose your own task, but that is you have some options. And the same with open source LLMs. The open source field was blossomed just maybe half a year ago since publishing Llama. And there are a lot of instruction fine-tunings, chat fine-tunings. It's very popular technique. And many models are fine-tuned to different teams to follow human instructions or to perform conversations. First, very popular was Llama. It was not truly open source, but it quickly emerged on torrents, and since then everyone fine-tuned it. But you cannot use it commercially, and Llama 2 fixed this. Right now you have good Llama with normal commercial license. You can build something and do not afraid about problems with due diligence and some legal cases. And each of these models subsequently produce better and better results. Llama was the original LLM by Meta, then Alpaca was some first experiment in instruction fine-tuning, Grigory was another experiment, and you see that they are still far from ChatGPT in quality, but it's getting closer and closer. Yeah, and Llama 2 is even better, so in Falcon we had a version with 40 billion parameters. Just a week ago, much larger version was published. It's the size of, it's hard to tell about the size of GPT-4, there are some rumors, but at least it's the size of original GPT-3. It's a really big model. It's tricky to host until you have a good GPU cluster. But it's here, you can already use it for some cases. And there are many other open source LLMs. I just mentioned some of them. It's not the whole field, so you see it's blooming, it's growing, a lot of different LLM emerged, so you can easily find some LLM, fine-tune it for your tasks. Here yesterday you had a great presentation about Hugging Face and theft and some other things. So there is a good support in Hugging Face library to use some model fine-tuning on your data and use it for inference. Bright future. Just a year ago we didn't have such ecosystem. But with open source, there's still a gap between best open source model and best commercial model. We'll see, it could change, but right now it's still different. And if you look at the leaderboard of LMC's arena, the top maybe 5 or 6 models are the top commercial models like GPT, Cloud Air, GPT again, Cloud Air again, and then starts Vicuna. And this is probably not the latest, or this leaderboard does not include everything. So you see that there are still gaps. Yeah, that's it with LLMs. You see big camp of commercial, big camp of open source, and open source grows enormously. Reinforcement learning is widely used. RLHF, or reinforcement learning from human feedback, is not a new topic, it's not a topic of 2023, but just to give some context, it's here, everyone uses it. Hugging Face library have good implementation, how to use it for fine-tuning, you can just call it in several lines of Python code, and it's brilliant. Just a few words of the idea of reinforcement learning from human feedback. You have some LLM, then you generate different results with this LLM, and then you ask humans to rank these results between different parameters of this model. You collect these preferences, and then you take another instance of the same LLM and fine-tune a special model that will learn ranking of these answers. So this is called reward model. And after you have a reward model, you can run reinforcement learning loop. One LLM generates different answers, another LLM fine-tuned one reward model ranks them or assigns them score or rewards. And by classical reinforcement learning algorithm like PPO or some other algorithm, you just fine-tune the original model that generates results to produce results with better quality. And that's it. You run this loop. Why you need reinforcement learning here and this reward model, just because you cannot establish this high bandwidth channel with rewards by humans. So you put another model and run it and train that model. That's it, that works. And returning to the paper about institutional AI by Anthropic, they improved this technique a step more. Now, instead of reinforcement learning from human feedback, they invented reinforcement learning from AI feedback. Now, even this ranking or even these quality estimations of model answers generated by another LLM. So they actually measure the quality by two axes. One is helpfulness, another one kind of harmfulness. So helpfulness, I remember if I correct, was measured by humans, by harmfulness was assessed by another model with special prompts, and that's it. You run this loop again, and it works better than standard RLHF, so they produced model with better quality. That's interesting. And again, here we are returning to the prompt engineering. You achieve it just by combining different prompts. You write a prompt so the model can evaluate the output of another model. You write prompt that rewrites the output of the model given the critique of another model, and you combine it multiple times. Again, you are limited only by imagination. You can create many prompts, many step procedures, and finally maybe you can get rid of human in this loop at all. Who knows? Okay, LLMs go to search. Again, nothing new. Bing integrates OpenAI model. Google integrates their own PALM model. It's called BART here as an engine, but behind BART is still PALM 2 model. You probably know about, how many people don't know about a startup called Yukon. It's created by Richard Zucker, interesting man, specialist in NLP. So another search engine with LLM inside, so that's an interesting field. And just before me, Vova told a lot about.
That's a question.
Yeah.
I frequently use that,
Yeah.
and when I compare the output of you and output of any of ChatGPTs, they are like so different, and they are kind of mainly linking to the, and that they are linked to the place on which they are generating their answers. They are mainly so different. I mean, like China and USA, and you know what's behind that, because this is, I mean, ChatGPT is mainly more structured, a bit better, but this is, I mean, probably more informative.
Yeah, but they are completely different. They have different training procedures. They have different data sets.
Do they have any different? Or?
Not sure, probably. Yeah. And there is a lot of, how to say, business logic about it. To control the output, to control what to...
Because I have a feeling that they are kind of using probably some translation from Chinese or Japanese or some Asian languages.
They
and
might.
then they kind of use that translated text to generate it, because they go, I mean, they link to the websites which do not have an English, English pages. They can only go with the Google Translate and see that that's what they are written with there. Yeah.
Probably use it, and that's a good point. We'll return to translation soon. Yeah, they're very different. They're far from perfect, but it's a very interesting experience happening right now. So again, we'll see how it will work. And just a few words to say that information retrieval augmented LLMs is completely not a new thing. It has pretty decent history. And before me, Paul told about external memory transformers. That's part of it. And another thing is right now you can use tools I mentioned before. It's another way to add memory and search capabilities to models that maybe even didn't train to understanding of this possibility. That's developing right now. And here we're coming to software ecosystem. It's again changed. You heard about LangChain, you know this library. It's very popular. I personally do not use it heavily because actually for production use cases, for me it's easier to use calls directly and many other things. But still it's a good and very high adjusted field. We'll see. At least it's easier to start using these models right now, thanks to LangChain as well. It's helpful, at least for experimenting. So it's a big major player right now. And another big major player, not a single one, but the full field, is a vector database. A lot of different vector databases. I will not talk about them at all, but you know they are here. They're used to retrieve text and augment prompts. They're very popular. And the interesting thing is if you try to zoom out and understand what's happening in the field, I like this paper by Schmidt, Huber, and some other really cool researchers. They looked at what's there and proposed the concept of LLM programs. Actually, nothing new here, but the idea is with classical prompt engineering, you put everything into the prompt and then you rely on model. Models should track the context, models should do everything. It doesn't work reliably in many cases. In many cases, it's much easier to split the tasks into separate steps and control the LLM outside just by Python code, for example. And the idea of LLM programs is exactly that. LLM is not responsible for maintaining the current state of the program, and some external code, maybe simple Python script, just determines which data to put into the prompt, which exactly prompt to use, and that's it. Basically, LLM chain works in this paradigm. Nothing new again. But I like this this idea, this point of view helps to structure and to systematize what's there and what to expect. And another advanced techniques, kind of the standards of chain of thought, or tree of thought, or graph of thoughts. Each month some new technique emerges. If you look inside these techniques, you always surely find something like controller. It's a program that controls LLM, and again that fits into this concept of LLM programs. There is something external that uses LLM, and in this way you can achieve much more reliable results and increase quality of solving many tasks. That works, and I personally believe that will work. It's a good approach, which I'm expecting when the first programming language with LLM as the first class objects emerge. We'll see. Right now there are no such language, but I believe not too far to that point. And another interesting example called AutoGPT. Someone wrote a code that you put description of the problem you want to solve, and then these things decomposes around external tools and in the loop trying to solve your problem. Not extremely helpful for now, but it's a very good example of what is possible, and I particularly like that the GitHub repository of AutoGPT got twice more stars than PyTorch has right now. That's surprising. That's a signature of hype as well, but it's still interesting phenomenon. Keep an eye on this project that could evolve to something interesting. It's not the only one project of such type. There are some others. It's in this direction. Yeah, and to the code. Again, here you had today great talk about models. I just briefly mentioned that there are models that produce code right now. There are commercial models like Codex. Some of you probably use GitHub Copilot. I use it sometimes. It helps to do boring stuff much more quickly. I like it, and some of my friends can use it to write tests, or use it to speed up or write their code. It works. And now we are in the era when open source models are available. Again, it's a question of their quality, but in the long run, you'll have some good model that is available locally to you, and you can use it we'll see, for writing code on their own. Wizard Coder is another model. Again, there is a gap between GPT-4 and top commercial models and this open source model, but it's closing. The gap is closing. There are many models. Important thing is multilinguality. Just some brief context. Actually, many models available right now, GPT-3, GPT-4, Bloom, and others are multilingual. Some models are multilingual by design, like Facebook NLP 200. It's the model to translate between 200 languages. It's open source, it's published, you can use it. But other models like GPT-3 was not trained to be multilingual. They just was trained to predict the next token. And in the data set, there was a mix of different languages. And suddenly, these models learned to translate between different languages. And they learned to translate well. I return to it soon. But long time, there was a problem with multilinguality. There was a phenomenon called curse of multilinguality. That means that in a model of some size, if you want to add more languages to this model, you kind of have a trade-off. You can achieve positive transfer. Positive transfer means that by adding new languages, you improve quality on other languages as well. But at some point, high resource languages degrade, like English, Spanish, or other. But low resource languages, like Welsh, medium, there are no huge data sets for or other languages, they improve in quality. So that was a problem, and it was hard to train a really large multilingual model because we have to balance here. But in 2021, the first time in history, I believe, multilingual model beats every monolingual model in a competition called WMT. It was Facebook model. And since then, Facebook continues to publish their new multilingual models, and the quality is getting better and better. And right now, we are in a position when multilingual model is typically better than a single language model, or at least two language model from. And it's an interesting point in history. And Google has its own initiative called 1000 Language Initiative. Again, everyone, not everyone, but many large companies trying to build models that are heavily multilingual and also make multitask. So that's an interesting time right now. And here we return to machine translation. Again, we as a company produce machine translation report each year. You can download it freely. Here's a link. And here you can see just a landscape of different vendors. There are a lot of different machine translation models. And here I just put only commercial one. There are some pack of open source models as well. And each year, new languages, new language pairs to translate emerge. And just to get a sense of what's happening, last year we calculated that together all these models are 125,000 different language pairs. That's a pretty decent number. But this year, this number grew almost to 200,000 different language pairs just in 1 year. And next year we'll probably see much more languages. Right now, the direction is towards low resource languages. There are still a limit of how many languages you can incorporate. Not so many languages on the earth, but we have a hard cut. But still, we are going there, and probably soon many languages will be covered. That's really great. And also 5 seconds of PR. We have a machine translation university. Again, it's free materials if you want to understand what's machine translation, how to control it, just read it if you want. What's interesting here? First, machine translation is disrupted by large language models right now. I am personally fond of this prediction I made in 2021 that prompt and translation model should emerge in 2022. It emerged. And right now there are different prompt and language models, and you know them. It's GPT-3 and 4, for example, but not only. And we measure the quality of GPT 3.5 and 4 on machine translation tasks, and we see that the quality of translation is on the level of the top machine translation engines like Google, DeepL, and others. It's really great for the model that was trained for predict only the next document, and that was not deliberately trained to do machine translation. Some machine translation systems might be replaced by LLMs soon. I personally believe in it because, for example, if you look at Palm 2 paper by Google, you see that they compared quality of machine translation by Palm 2 with their current production Google Translate system, and the quality of Palm 2 is higher, better. The only problem, I believe, is that Palm 2 is much larger than the current Google translate, so they have to solve different engineering tasks to do it efficiently. But from many examples of different companies, we see that the trend is towards LLMs, and probably some translation will be replaced by LLM, or at least you, as a user, already can replace translation by LLM, and it works, and it's also cheaper. GPT-3 is cheaper than Google Translate production, or DeepL, or whatever, something like 10 times cheaper. So why to use machine translation from expensive vendor when you can get decent quality from cheaper? Yeah. And with LLMs, you can solve much more interesting tasks. For example, to translate between inside the same language, between dialects, for example, or between variation of languages. You can translate between Spanish and Argentinian Spanish, or between French and Canadian French, or between different dialects and Chinese, Russian, whatever. It works. Again, sometimes not perfect, but it's pretty good, and commercial and machine translation vendors sometimes just do not allow you to use something like this. And the trend is that translation replaces translation. What do I mean? Historically, the workflow was you created some text in some language, say in English, and then when you need to produce something like this but for other languages, you just translated it, and that's it. That was the main direction, because it was hard to create text on different languages at the same time. It's almost impossible for many cases. But right now, with GPTs, for example, you can write some brief, what you want to generate, ask to generate it on different languages, assuming some different cultures, and it will generate different emails, different blog posts, understanding the cultural differences, what to mention, which example to use, if it works. And here, just a simple example from how to paper as well. Probably it's hard to see, but they asked to describe, to generate, invent a computer game with the character described in Armenian. So I'll let you to evaluate how well it works. And you actually mix different languages in your brief, and then the model generates accordingly. That's a great example, and this way, this trend will develop further. It's a really nice and interesting trend, and it's very fruitful. But still an important theme. Machine translation and LLMs still need each other. What I mean? First, machine translation helps LLMs. In what way? Data sets are still dominated by English, and all these GPT, PALM, and other models are still heavily biased towards English. And it's no surprise that in English they solve tasks better than, say, in Russian, Spanish, Armenian, and other languages. Spanish is probably okay, but for some languages it's definitely worse. And one fresh paper this year, the authors demonstrate that if you take some LLM, it was, I don't remember, probably some Falcon, some open source LLM, and ask it to solve different tasks like verbal reasoning, maybe something else, I don't remember exactly. And you have two options. If you want this model to solve different tasks in different languages, say in Chinese, you have two options. You can ask in Chinese, and the model will solve somehow. Or you can translate to English, solve it into English, and translate back to Chinese if you need it. And authors showed that if you use the original language, you have some quality, but with translation through English, you obtain much better quality. And interestingly, they also used what they call self-translate. You ask the same model to translate this text to English, then process it, then translate back. And even this is better than using the original language. That's surprising. That resembles a bit a chain of thought or some multi-step procedure. That's exactly it. So right now, machine translation really helps to produce better results for some languages. If you have a task that involves not English but some other languages, it makes sense to try translating and solving your task. But that's not the only thing. Another thing is that all languages are not equal. I mean, the problem is tokenization. because tokenizers are trained on data. Again, if you train mostly on English data, the English tokenization will be the best and the most economic in the informational theoretical sense. So the same text in different languages produce very different token sequences. For example, the text about the weather next week in English generates 7 tokens. The same text in Spanish generates 8 tokens. But for other languages, it's much more tokens. In Amharic, it's just 9 times more. It's a lot. What's the problem? The problem is the context window is limited. So the context window is limited by, it's about number of tokens you can put into the model. So if you want to work with large text, and these texts are not English, you have a problem. Text in Amharic probably will not fit into the same model, but the text in English will fit. That's one problem. And another problem is just price. If you use GPT-4 with pricing per token, doing the same thing in English and in Amharic will lead to 9 times difference in price. So that makes sense to use English for some tasks because it's better quality and it's cheaper and you have longer context. That's interesting.
And better speed, actually, speed of generation.
I agree. Yeah. So English still has the shortest median token length right now, and you see Armenian is not in a good position here. Again, 63 tokens in average. Not average.
Well, we also know that if you have a longer output, it gives more chance for computation for the model. And so with Armenian and Burmese, maybe you get the smartest answers.
That may be a factor, but still there are some limitations. And to the reverse side, LLM helps machine translation because you can do very different things. You can pre-process text before translation, say fix grammar, to fix everything you want, to change style if you need, and you can also fix output. For example, if you translate, say, from English to Russian or some other language that has formal and informal you have to control on the formalities of the text. And if machine translation engine does not support it, there are only a limited number of engines that support tone of voice. You can use LLMs for that case of gender correction and to apply specific terminology. There are a lot of applications where LLM can improve for translation output, and that makes sense to combine them. So, how much time do we have? Almost the last thing, or maybe the first one before that, multimodality. Right now, multimodality is a norm, and not everyone knows, but GPT-4 is actually a multimodal LLM. By multimodality, I mean that the model can consume or produce not only at least 2 different modalities, like text and sound. So GPT-4 originally can consume text and images. It's still not available in API, but internally it allows placing images to the model, and the original paper about GPT-4 contains beautiful examples when you pass some text, some images, and asking the model to answer questions about the images. And again, there are a lot of probably cherry picking there, and the example looks brilliant. Model kind of understands the image, and it's great. We already there. Maybe not this year, but next year it will appear in API. And anyway, if it will not appear in GPT-4, it will appear with some other language model. We will have different multimodal models like PAL-E, embodied PAL, or Microsoft has model Cosmos 1, Cosmos 2. DeepMind had a great model called Flamingo. It's a visual language model. Again, it can work with images and text. It's not available because it's closed inside DeepMind, but this year 2 Flamingo productions happened. First was Open Flamingo, and recently another model called Pidetics emerged. It's much larger. The original Flamingo, I believe, was really large, not not 9 billion parameters, but new open source Flamingo called Intento has a larger model with 80 billion parameters, so it looks interesting. You can download it and try for your own tests. And that not the only examples of multimodality. Google has a universal speech model called USM, trained on both text and audio, and supporting 300 languages. Meta just published their seamless M4T model that can translate between languages, between audio, translate between text, generate text by audio and vice versa. So it's multimodal model that can consume both text and audio and generate both text and audio. That's really cool. You can start using it. Again, there are risks with it. At the beginning of the year, there was a nice example of how someone hacks the Lloyd's Bank security just by creating the voice of someone else and performing some operations. Yeah, that will happen. It's kind of two-edged sword with this technology. And another interesting work is DynaLang, or if you follow their research direction about world models and agents, you probably heard about Dreamer type of models, and they recently published a paper called Dreamer version 3 with some LLMs. It's an agent, a reinforcement learning agent that can navigate in some virtual environments. And the third version of Dreamer can also incorporate text hints about environments and some other things. So it's interesting thing on its own. It's more research than some production or product use cases, but it's still happening here and will probably lead to interesting examples. And DeepMind also had a very interesting model called Dato. I believe they should train Dato second version, much larger. We'll see. Image generation, stable diffusion, Midjourney. Again, these are examples of multimodal models because on the inputs they have text input, they have optional image input, and as a result they produce some images. Again, multimodality is here, so maybe next year it will make no sense to make an NLP presentation because many modalities will merge together and it will be hard to distinguish where NLP, where not NLP. It's already hard. Runway published their models for video generation by text. The first version was Gen 1, now they published Gen 2 model. And it can do very different things. It can generate small videos by text description. It can do stylization of videos by textual guidance and many different things. So just look at it if you didn't see it. It's really interesting. And final thing is about safety, legal, ethical issues, because last year a lot of different activities emerged here. Misuse and malicious use was a problem for a long time. Right now, with these capable models, it's even a larger problem, and there are still no good solutions to what to do with it. We just live in this world where we will probably face much more bots, much more automated propaganda, and much more anything else. We have to understand what to do with it. There are a lot of legal risks. Right now, it's mostly a gray zone in many cases. It's worth a separate talk on its own. There are a lot of ethical problems. There are a lot of, sorry, this slide is for the next year presentation. And right now, there is a huge push towards responsibility, transparency, different approaches. You probably heard about several petitions published last year. One of the most, I would say, controversial was to stop training all models more capable than GPT-4, at least for 6 months. Still no success. Another one was to implement, develop clear ethical guidelines, build some multinational framework, and so on and so on. Again, it's very hard to coordinate in modern world, as we see. Another one in the reverse direction by CERN, actually. Let's keep up the progress, but let's invest in open source, and the open source and openness of the community will help solve the problems, maybe, who knows. And another one completely different was about let's include consciousness research to the field, because you probably remember that last year one man from Google said that Lambda has consciousness, so we have to do something with it. And there was a huge hype and huge. There were a lot of talk about that, and I personally do not believe current models have any consciousness, but in the end, I don't believe that something prevents them to have something like consciousness. So at some point in future, we'll face these problems, so we have to prepare somehow, at least to understand, is it there or not yet. It's still an open question, no answers here, but it's already here. That's it. Again, if you read Russian and want to read about different research papers, it's my channel where I publish a lot of reviews of different papers. Another thing, I finally finished a book about JAX. It will soon be ready, so if you're interested in JAX, right. And that's it. Thank you. If you have any questions. Yeah, one question.
I have a question about languages, how the model understands that this is a new language, but not a new word in already existing language, and some, for example, different cities speak in slightly different language, but still this is one language. So how it decided that this is a new language, not a sub item of some language?
I think there are no answers for that question. First of all, I believe the model probably does not understand anything about languages, but by different correlations in the data set, the most probable tokens are still in that dialect you want to use. So I believe it's just statistics here. But internally, there may be some concepts emerging. You know, right now, there are no tools to understand actually what's there. If you have models with, I don't know, 100 billion parameters, it's impossible to understand which concepts are where in this model. It's too big.
How consciousness can be defined? This is the question. And is there any means to monitor that? So the fixed point when the model have consciousness?
I'm not the relevant person to answer this question. Maybe just 2 weeks ago, a large paper published about consciousness in LLMs, or in general in artificial intelligence. There are different approaches to consciousness. There are no single, generally approved one, so no answer. Even for human, I believe many people do not understand how to measure consciousness and what is it.
Okay.
Do we
First
have
of all,
times? Yeah.
First of all, really thank you for your extensive review, and thank you for Telegram channel. I didn't know that you are the author of this channel actually, and I
So
read
coming
you on
out.
a daily basis. Yeah, but quite a surprise. So, did you hear about the superalignment team of OpenAI announced it, and what's your opinion and
Oh, that's a good question. Yeah.
automating the alignment research? So their proposal actually is to automate the alignment research and solve the problem of alignments of superintelligence in 4 years. Like timeline says 4 years. So
Yeah, it's a really tough question. Actually, when I proposed the topics of the talk here on data first, NLP was one, security and security, actually, safety and some other things was the next one. So we decided NLP. I don't know personally. It's very hard to understand what to do in this particular topic because I believe we have no solution right now, and we even have no solution just for people because we have different people with different motivations, and they are definitely not aligned by what we see, what's happening in the world right now. No alignment at all. And if we cannot fix it for humans, I believe we cannot fix it for HI as well. Just no solution for now. And with automated, I don't know. I will be happy if they find some solution. At least we should try. But
What's your views about the world when we not find a solution and create a species with a higher intelligence than we are? What's your answer to that? Because the logical answer is we go extinct. That's it.
I have no answer. Actually, I'm afraid we can get extinct before that
the
point.
motivation of the machine?
Mhm.
What's the motivation of the machine? I mean, as far as we do not define what the motivation of the machine is, like extinction problem is just a vague fears.
Oh, there are a lot of scenarios. They might have no motivation, but some recursive procedure just can use all your atoms of something else, for example. Yeah, it's a very big topic. I personally believe that at some point in the future we'll see some super intelligence entities. I don't know. And I don't know what to do with it.
Okay.
What do you think about autonomous co-pilot LLMs? For example, Perplexity has co-pilot 5, or they are still in the hype cycle. And what's the future for the co-pilot systems?
Do you mean, what exactly do you mean?
Perplexity AI has co-pilot 5. When you do your prompt in Perplexity, and then they have co-pilot 4, 3, and so on. So the co-pilots, autonomous co-pilots have future. If they have future, what is the future?
Still didn't get. You mean copilots for cars, or you mean copilots for like Google or GitHub copilot?
Yeah, for Perplexity, for example. Perplexity is an example for such a copilot.
Perplexity.
It's a search engine
Search
which
engine.
summarizing Google results and would apply Copilot, Microsoft Copilot to write some codes of part. So you have mixed interface between classical search result, summarizing into these lightweight LLM models, and try to generate some code if your question contains something like generate code. So it's modern approach to searching. I use it this last 4 months.
He asks questions after the prompt. Yes, more defined. How do you want this to be done, and so forth. And the next question. We can
Helps you to write
yes,
code all.
to make the best answer.
I believe it should work. Yeah, finally. Why not? Or what's the question actually? Maybe I didn't get it.
Do you use Perplexity?
Perplexity, I don't use Perplexity, but I use GitHub Copilot, for example. I like it. Maybe Perplexity is a different thing, I just don't use it, I'm not sure.
It's fine for research.
Mhm.
It's very fine.
Mm.
Consensus. LSE.
Okay.
Hello, so I have a question. The next token prediction task is pretty much old task and well known, as I know. So what have changed recently to make GPT-like models to be so powerful?
It's hard to say because there are no papers explaining what's exactly happening in the GPT-4 and how to and so on. But I think it's just a matter of scale, better data sets, maybe some engineering tricks as well, but I think nothing besides that.
Just
Mixture of experts as well.
That's interesting why they appeared in the same time. Like they gathered all the available data in internet like in this point of time.
What same time? Actually, this is a very long story. First GPT was appeared maybe 5 years ago. Google has a lot of research previously. Lambda was more than a year ago. They just Right now, I believe synchronization happened only because OpenAI ran a lot of PR, published ChatGPT. Google have to do something because it had a lot of pressure towards doing that. So they published it, but there is development war almost there. And right now they're just scaling it. I do not see any significant changes in the architecture. Larger, better, more experts.
AI models, they do have their strengths and they do have their weaknesses, right? But as of right now, what do you think are top practical applications for them? In what spheres, what types of businesses could they be used first? And in what types of situations they are still they're not capable to replace humans, and what tasks they can already do better than humans?
It's easy to say where they cannot replace it. Some high risk tasks, like where human is required by some legislation, so law, medicine, some other things. It doesn't matter. It doesn't mean that they are bad. They might be good, but it's not possible to replace because human must be there, human must be responsible, and so on. And for what we can use it, actually, I think again we are in a position when technologically we can do a lot of different things, and right now we are limited by lack of imagination and lack of technology, and we are in the era like at the beginning of the internet. We can do many different things, and it's very hard to predict in which field we will go and what things will emerge. It's still an open question.
Sorry, my question is about GPT-like systems. So as we know, there is a knowledge cutoff for that systems, which is September 2021.
Yeah.
So my first related question is there a really powerful LLM that has like newer knowledge that is like that can be used instead of GPT? And also, what is your view, like how we can incorporate this new data into the LLMs before a newer model comes out? Like, is it the database vector stores, or we should like try to fine tune with new data until some new model comes out?
I'm not sure about other commercial LLMs. Probably some of them will have cut-off range later, but it's
Podcast, they announced that they fine-tuned exactly the newer data, so Claude has now like 2023 data.
Oh, that's great, that's great. And even in GPT-4, there are different versions, and they publish new versions with some schedule, so probably they will add it. But generally, I believe that's not a problem, because something like information retrieval augmented LLMs is the solution. You always will have a problem that LLM is not too fresh. I worked with news, and freshness was super important for news. You can train a model, then next day something new happens, and you need to push fresh data somewhere. And with LLM, with traditional training, you cannot solve it at all. With constant retraining, it doesn't work. There are some architecture with databases with facts and with information retrieval, and something like this, I believe, with the solution is the most straightforward solution, and I see it works, and I see no reasons that there should be something better right now. So I think that's the best solution.
What is believed to be best open source ChatGPT competitor for now?
Please define the best.
There are some, I think,
there are no best anything. It heavily depends on your case. You have to measure how different models solve your particular task, because usually what happens, the model landscape, the quality in different domains and different settings are very different. So you have to measure on your particular tasks, and that is the only reasonable way to understand what to use. No other rankings, no other leaderboards. It's just for general understanding of the capabilities, but that doesn't mean you should take the number first.
But what they measure those video bots? Do they measure anything meaningful?
They usually run some well-known tests, like there are a lot of NLP benchmarks. They use some of them, but it's not much sense to use them for some other tasks.
Then what could be the best large language model for competing with translations?
Again, it heavily depends on what we translate, which languages we use. So the best will be the model that works best on your data, I'd say this way. And no single bullet here, really. Very different models, very different quality, just you have to measure.
And the last question, what could you say about Gemini, the Google's Gemini? What features it will have, approximately what features it will have, and how it will differ from all other models, Claude 2 and Gamma 2 and so on?
I don't know, Google is so closed. No answer. Probably multimodal, probably, I don't know, multitask, probably pretty large, probably information retrieval augmented. I believe that Google should use Google API because they have one of the best data sets in the world. I don't know what else. Maybe embodied, but I'm not sure.
A question about how to measure the quality. We have tests, and they can easily check that 2 plus 2 equals 4, but something like tell me a story, how they check the quality of this kind of answers.
Yeah, it's very tricky. You usually have to involve humans in the...
So only humans?
It depends on the task, but it's better to have humans because it's hard to formalize such tasks.
Yeah.
Again, you can use other LLMs to evaluate, but there is a bias. And it's very complicated question.
So only humans checks.
Even with humans, there are problems because different humans can read differently. Yeah, with machine translation is much simpler than storage generation, but even with machine translation, for one sentence you can have very different translations that are valid. Yeah, and it's better to have some domain expert that validates this particular output, and it's better to have different experts to look how are they aligned, because if they're misaligned, it means something. Maybe the task was badly defined, maybe the problem is really tricky and you cannot use simple human evaluations. It's a very complicated question.
So those popular measures are not for text generation, but for some mathematical
There are metrics for text generation, and probably Rouge metric used in generation, maybe other metrics. But again, still, it assumes that you have some golden reference against which you will compare. But in many cases, there are many golden references. There are many results that would be good. And if it's measured as a really good system against this particular reference, but suddenly there are another one, even better reference missed.
especially in science, different opinions.
Yeah, the problem is it's a very poorly formalized domain in storage generation. It's easy to evaluate well-formalized settings, but for such very open settings, it's a problem. But humans is the best option right now.
I came across a problem with using OpenAI for writing code. I gave it a prompt like write me a Python code for this particular problem that I have, and it wrote some Python code, and it gave me the expected result. Like this program's output is going to be this table, like 2, 3, 4. But when you just copy paste the Python code that it generated, the result is completely different. Some tables, some columns might be missing, or the numbers are completely different. Why doesn't it just check what it supposed to output, like it seems like an easy check to do.
Yeah, good idea for startup. Just incorporate LLMs and some business logic above it.
Actually, the reflection paper stated that models can reflect on their previous output. So you can just say, is it correct? And it will make your output better.
Yeah, the problem is only that the process is built that way that the output of the model is the end step. That's it. You can run some loop.
Okay, it makes sense. So it's not supposed to recheck itself. You have to force it.
It just generate tokens and that's it.
Okay.
You have to force it.
But still this model can't run the code inside the...
It can, with tools it can.
So it will use the virtual machine to run?
GPT-4 has plugins and code
So
interpreter.
Plugins, but the text that they suggest in the result is just text for the LLM, right?
Yeah, but it's easy to add your own code
Yeah, I
to run
understand,
Python
but
interpreter.
still it considers this as a text,
Yeah,
as a
it's
research
just-
text, not as a code.
Yeah, exactly.
Various domain-specific language models are emerging right now in the field of natural sciences, like, for example, chemical, protein, DNA, RNA language models,
Yeah.
and so on and so forth. Do you think that such straightforward applications of NLP foundation models are going to disrupt biomedicine, etc.? Or do we need more niche-specific approaches?
I think both. They should disrupt, but domain-specific models definitely could be much better. Like AlphaFold, for example, is a very special model. It's really great, and I don't believe LLM can achieve something like this because it's completely irrelevant here. But in other cases, LLM could be great, for example, and I see a lot, saw previously a lot of examples, for example, molecule generation. LLM works well in generation. It could be good, but again, it depends on particular domain. So should we end? Okay, thank you. If you have any questions,